In this video, we're given the fact that the derivative of e to the x is just equal to itself. It's the only function that works this way, except I suppose for 0, but that would be trivial. And we're going to combine this rule with the chain rule in the first example. And then we're going to go on to generalize to a base other than e, and then look at a specific example of that. So let's get started with this. I want the first derivative of f of x equals e to the 3x. So f prime of x. Well, this is a function of a function where the inner function is the 3x. So we differentiate e to the 3x with respect to 3x, treating the 3x like it's just a single variable. And that just gives us back e to the 3x. That's the very simple derivative behavior of the natural exponential. But the chain rule says now we have to tack on the derivative of 3x with respect to x, and that's 3. Cleaning it up a little bit, that's 3e to the 3x. So that one's done. In the next example, we're really asked to derive. How do you find the derivative of an exponential function with a non-standard base? And I suggested using a natural log here. So the idea is natural logs are very good at giving you access to exponents. So what if we just took the natural log of both sides? Y is equal to b to the x. Let's take the natural log of both sides. And here's the point where we get access to the exponent. I can use a log rule on that. All right. And a lot of books call this logarithmic differentiation, but really all it is just using the chain rule on this. So I'm going to differentiate both sides. And the natural log of y, because y is a function of x, this is a function of a function, and I'm going to use the chain rule when I differentiate with respect to x. First I differentiate with respect to y, and I get 1 over y, and then I have to tack on the derivative of y with respect to x, because y was the interior function on that. And then on the right hand side I differentiate with respect to x, and natural log b is just a constant, so I end up with natural log b on the right hand side. All right, then the point is to solve for dy dx. That's the derivative of this non-standard exponential function that we started with. So I multiply both sides by y, I get y natural log b, and then I can plug in what y actually is, which is b to the x. And normally you'd put that constant out in front. And so I have y prime is equal to natural log b times b to the x. So it almost works like e to the x, where I get back a copy of the original function, but there's this slight modification where a factor of natural log of the base is produced. So when we apply this to 3 to the x, we can just directly use the formula that we just derived. I end up with natural log 3 times 3 to the x, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.